Properties of haloalkanes and haloarenes. Here we are going to discuss about haloalkanes and haloarenes. The haloalkanes are also known as alkyl halides, and that is a group of chemical compounds which is comprised of an alkane with one or more hydrogen, and that is being replaced by a halogen atom. So, haloalkanes are the compounds containing halogen atom attached to the sp3 hybridized carbon atom of an alkyl group. For example, we could take it as monoalkanes, dihaloalkanes. We could have it in multiple way. And haloarenes are also the hydrocarbon which is composed of the aromatic ring with one or more hydrogen atom, and that is being replaced by halogens. Haloarenes are the compounds containing halogen atom which is attached to sp2 hybridized carbon atom of an aryl group. And we could have different types of haloarenes, that is monohaloarenes, dihaloarenes, trihaloarenes. So, the replacement of hydrogen atoms in hydrocarbon, aliphatic or aromatic, by halogen atoms will result in the formation of an alkyl halide, which we call it as haloalkanes, and aryl halide, which we are calling it as haloarenes. There are different properties of haloalkanes and haloarenes. So here we are discussing about the physical properties of haloalkanes and haloarenes. So first let us discuss about the physical properties of haloalkanes. So basically alkyl halides are colorless in pure state. Bromides and iodides, they are cultivating color on exposure to light. So, intermolecular force of attraction of halogen derivatives are considered to be stronger due to greater polarity and molecular mass as well compared to the parent hydrocarbon, will be resulting in higher boiling point of chlorides, bromides, iodides compared to the hydrocarbons of the same equivalent molecular mass. Few more properties what it says is density. When we talk about density of haloalkanes, it increases with increase in number of carbon atoms and halogen atoms and atomic mass of the halogen atom. So density is going to increase if the number of carbon atom, halogen atom and the atomic mass of the halogen atom is increasing. So we could say density is directly proportional to the mass of compound. Hence, down the homologous series, density will increase and also their fluoroderivatives are going to be lesser dense than chloroderivatives, because chloroderivatives are even lesser than the bromoderivatives, and so on it goes on. And haloalkanes are polar in nature, yet they are practically very slightly soluble in water. For isomeric alkyl halide, the boiling point will decrease with branching, and for the same halogen atom, the boiling points of haloalkanes will increase with increase in the size of alkyl groups. So these are considered to be the properties of haloalkanes. Let us see the properties of haloarenes. So, aryl halides are colorless liquid or colorless solids with characteristic odor. The reason for the development of color in the decomposition of halogen in presence of light. So, the reaction will represent the phenomena is 2R, I will give us R bonded to R plus I2. So, boiling point generally increases with increase in the size of the aryl group or halogen atom. Boiling point order, we could say it as aryl attached to iodine, bromine, chlorine, fluorine in that sequence. If we talk about the melting point and boiling point of halogens atom, it increases with an increase in the size of the aryl group. Para isomers will possess high melting point compared to ortho and meta isomers due to the symmetry of para isomers fitting in the crystal lattice better than ortho and meta isomers. Few more properties if we talk about haloarenes is because of the resonance in chlorobenzene, chlorine and carbon bond will be shorter and hence the dipole movement is less than that of cyclohexyl chloride. And dipole movement is totally going to depend on the difference in electronegativity of carbon and halogen. And haloarenes are considered to be heavier than water. Haloalkanes and haloarenes, they will neither develop new hydrogen bond nor it will break the old hydrogen bond. Hence, the solubility is going to be low. However, these compounds are basically soluble in organic solvents because of the low polarity of the organic solvent such as ether, benzene, etc. So these are all the few physical properties of haloalkanes and haloarenes.